To meet the problem of supply, important to any amphibious operation, the Navy depends in large part on the LSM, Landing Ship Medium, a rugged, ocean-going pack horse that combines power with performance and utility with versatility in long runs to friendly bases or enemy beaches overseas. She's 203.5 feet long with a beam of 34 feet. 3 ballast tanks in the forward section can be used to store fuel oil, to trim the ship once she's loaded, or to add buoyancy to the bow as an aid to retraction. In addition, her flat bottom makes it possible to set her high and dry on the beach. Her forward draft, when loaded, is only 3 feet 2 inches. For its size, the LSM is one of the most maneuverable ships afloat. This is made possible by 2 spade-type rudders and twin screws, with 2 solid-type 3-blade propellers turning outboard, powered by 2 freshwater-cooled diesel engines capable of delivering 3,600 horsepower. 2 ship service diesel generators provide as much electric power as an LST. She has a flank speed of 14 knots, a cruising speed of about 13 knots, and a cruising radius of 3,500 miles. The cargo deck will hold 5 medium or 3 heavy tanks, or a payload maximum of 165 tons. It's enclosed from bow to stern by the superstructure deck. Space for compartmentation on both sides is utilized for machine shops and stowage space, the average size being the same as this surgical dressing room, used for the treatment of superficial operational and battle injuries. Plenty of fresh water is provided by an evaporating system that produces 2,000 gallons of fresh water a day. Rising 22 feet above the dead water line amidships and to starboard is the wheelhouse and bridge superstructure. The wheelhouse contains SO-8 radar equipment and instruments for steering and navigation, including the gyro compass steering repeater, the rudder angle indicator, the annunciator fitted with wrong direction warning stops, and the electric steering gear. Other electric control and emergency hand steering gear is located aft. The ship is controlled from the conning station above the wheelhouse, protected by a splinter-proof steel shield. The con is fitted with a standard compass, a gyro repeater, polaris and stand, a rudder angle indicator, and a 12-inch searchlight. At the bow, the forecastle presents an outstanding silhouette for identification, mounting a single 40-millimeter anti-aircraft gun, an ammunition and bosun locker, and the bow door and ramp, whose operating machinery is located below. A 750-pound bow anchor is provided, attached to 90 fathoms of 1-inch wrought iron stud link chain, secured to an anchor windlass on the superstructure deck, port side. Aft, a 2,000-pound stern anchor holds the vessel to in beaching and is used for hauling against in retracting. It is secured by 150 fathoms of 1¼ plow steel wire cable to the stern anchor winch on the cargo deck, port side. Because she is most often loaded with inflammable cargo, the LSM has one of the most elaborate firefighting systems for any ship of its size, including chemical and foam apparatus such as this CO2 unit, which can smother any type of flame without damage, this automatic aerofoam pressure proportioner unit, and a more than average number of fire plugs opening on the fire main, in addition to automatic sprinkler and foam systems in the engine room space. 2 portable handy-billy pumps can be moved anywhere for quick use in firefighting or in damage control. She's not a fighting ship and mounts a minimum of machine guns for protection, such as this single Army-type 40-millimeter on the bow and 4 20-millimeter anti-aircraft machine guns, 2 on each side, port and starboard. Not much, because she depends on horsepower rather than firepower, and can turn in her own length if necessary. The 20s are fitted with ring sights or with automatic Mark 14 sights. Briefly, that's the LSM, a cruising carry-all whose ship's company consists of 48 men and 4 officers under the command of a lieutenant senior grade. His battle station is in the con. The executive officer and navigator is a lieutenant junior grade, who is also damage control officer in charge of the forward damage control party. Communications, including radio, radar, sound, and visual signals, is in charge of an ensign, who is also gunnery officer with a battle station in the con. The engineering officer, an ensign, is in charge of the after damage control party. The primary mission of the LSM is to put materiel where it's supposed to go on time and in full force. And because it beaches and retracts itself in direct violation of the primary rules of seamanship, the commanding officer must see to it that his crew is well trained. For example, we're on a beaching exercise. All information regarding the location of the landing area, the kind of bottom, depth of water, set and drift of current is carefully computed. General quarters. Condition 1 brings the entire ship's company to readiness when we're about 30 minutes out. If this were a newly taken beachhead, we'd be ready for anything in the way of high-level bombing or low-level strafing attacks. We're not exactly bristling with big guns, but we'd be able to give a pretty good account of ourselves in protecting whatever cargo we might be carrying. On the forecastle, where the firing range is comparatively unobstructed, 5 men serve the 40 millimeter. 3 men comprise the crew of each of the smaller guns. And since there is no director control, all of the talkers are in telephonic communication with the gunnery officer in the con. When the commanding officer is satisfied as to the actual point of landing, we go into condition 1 mic. That means we prepare for beaching. Forward on the forecastle, the bow doors are made ready for opening by the bow door and ramp detail, which loosens all dogs, turnbuckles, and fastenings. Then the turnbuckles and dogs that secure the ramp. You'll need your overshoes for this job, Mac. When all couplings and fastenings are broken, the machinery that raises and lowers the ramp is tested. And the same with the hydraulic machinery controlling the bow doors. When this is done, the forward section is reported manned and ready to the con. We hold her down to 1/3 speed to avoid forcing her down by the head. And then open the bow doors. At the same time, we're busy astern, where the gasoline-powered anchor winch is warmed up. The stern anchor detail makes sure the telephone and power circuits are in working order. One hand for the ship, the other for yourself as you unfasten the anchor stopper, or you'll be left wet and very lonesome. With all gear ready, the phones tested, and the stopper off, the stern anchor detail reports the station manned and ready to the skipper on the con. We're beyond the breaker line, about 3 lengths from the beach, when we let go the stern anchor. We play smart and let go plenty of cable to provide more leverage on the anchor when the time comes to retract. The ramp is partly lowered to save time on the beach. If we were coming in under enemy fire, we'd hold it closed as a shield against small arms fire. This time we're in solid. A good beaching, high and reasonably dry. We hold her on by keeping the engines running ahead at a suitable speed. Our helmsman maintains the course to prevent broaching or drifting off in a current. This way, we'd continue to inch up on the beach as the cargo was unloaded. LSMs are cargo carriers designed to accommodate all types of motorized equipment and other loads of complete diversity. Tactically, they are extremely useful in beach-to-beach operations where they are most helpful in moving combat units quickly and easily to whatever points are designated as being strategically advantageous, providing a shuttle system that can set a pace for the movement of materiel and supplies. Each LSM has its own loading officer, but all cargo is handled by whatever organization it is being transported for, not by the ship's company. And although the loading officer may be called in emergencies to supervise stowage, it is usually the job of the troop quartermaster to make up the loading plan. Each inch of space can be utilized in critical operations. Since there are no hatches to hinder loading or unloading, equipment can be put aboard under its own power or by means of derricks and cranes, an important factor where time and dock space are at a premium. But at the same time, the cargo deck is open to weather and saltwater spray. For that reason, anything that can be damaged by moisture must be waterproofed. This is true especially of artillery. The LSM does a big business hauling tanks and can handle 6 of the medium-sized jobs. Or in the space you see here, she can carry 9 ducks, 5 LVTs, 4 105-millimeter howitzers with prime movers, 4 155-millimeter howitzers with prime movers, 8 75-millimeter pack howitzers, or 6 M7s. Underway, she rolls a good bit. Most strain on the cargo is exerted athwartship. Extra precautions are taken in the case of the heavy stuff in matters of lashing and chocking, always following the advice that it's better to be safe than sorry. Heavy items that break loose in transit not only damage themselves, but endanger the rest of the cargo and the ship itself. At all times, the skipper must be satisfied that the load is stowed properly and that the ship is in every way seaworthy. When we're ready to retract, we begin by backing all engines full. Next, a heavy strain is taken on the stern anchor. Now is the time when the captain and the stern anchor detail must be alert to be sure the LSM is moving out and not the anchor being hauled in. Sometimes she sticks her nose in so far she's cranky about getting off. Here's how she can be persuaded. First, an order to the stern anchor detail to slack off on the cable. This is where horsepower counts. Now, one engine is put full ahead, the other full astern. This will swing the stern to one side. If she's really in solid, you may not be able to notice any movement at the stern, but you can read it on the compass card. Keep pouring it on till all the thrust to one side is fully expended. Then reverse the procedure so the ship bores a pie-shaped wedge in the other direction. This will make a hole big enough to slip out of, so that when all engines are backed full and a suitable strain taken on the anchor cable, she'll let go. As soon as the ship is clear, all engines are stopped to avoid overrunning the anchor cable. Thereafter, she can be hauled out by the anchor alone. Remember, you have plenty of power and a great deal of stern maneuverability. The combination of the two is usually enough to overcome any retraction problem, as well as many another situation where the ability to get up and go is important. It's always a good idea to button up as soon as possible. This affords immediate protection against gunfire from the beach, lessens the danger of ruining the bow door machinery by putting too much pressure of the resisting seawater against it, and streamlines you so you can get underway at high speed with a minimum of resistance to the wind and water. Not every exit is as easy as this one, but this lady is made for cooperation. Smart handling, backed up by smart seamen and smart seamanship, get results from this vessel that can go farther than an LCI and get there faster than an LST. If the tactical situation requires it, she can fog up the place to aid smoke operations or provide her own cover from shore fire. So there you have it, the LSM. She's well behaved on the beach, plenty of speed, and a good cruising range, lots of power, maneuverability, and a good carrying capacity. She can haul anything, from K rations to cannon, from tanks to tomato soup. She's a utility ship as good as the crews that man her, a rugged sister in the family of ships designed to deliver the goods wherever and whenever they're wanted, over the seaways of the world.
Okinawa, the LSMR sees action for the first time. These are interim LSMRs, LSMs adapted for rocket firing but not designed for the job. Other conversions have preceded them. The WFS fired 120 7.2-inch demolition rockets from a converted LCM. Best known are the LCI conversions, with various combinations of rockets, guns, and mortars. They carry about 300 beach barrage rockets. Then the first LSMRs, longer range, better seakeeping qualities, carrying bigger guns and more rockets. Some interim LSMRs fire 3.5-inch and 5-inch aircraft-type rockets. Others carry 1,020 5-inch spin-stabilized rockets in their launchers. This is the most accurate, longest-range rocket yet developed, but its full potentiality is not realized when it can only be aimed by maneuvering the ship. These early LSMRs are carrying a weapon and not using it to full capacity. They're interim ships. Fast conversions rushed to action while newer, more powerful LSMRs were being designed and constructed. Here is the new LSMR, a ship with many weapons. Twin hoist-loaded automatic rocket launchers, one dual-purpose 5-inch 38, twin 20s and 40s, 4.2-inch mortars. 4 or 5 destroyers could produce the firepower of this ship, but their effectiveness for other tasks would be reduced. The LSMR, designed and armed for the job, takes part of the fire support load from other ships and frees them from the wear and tear of continual bombardment. The LSMR is built around the standard LSM hull and power plant with a range of 12 to 15,000 miles at 13.2 knots. The ramp and doors are removed. On later models, the bow is redesigned to improve seakeeping qualities. The superstructure is completely new, all placed aft to leave an unobstructed field of fire forward and on both beams. All that's left of the original LSM, except for the hull and engines, is the beaching gear. But the important thing, the reason for this ship's existence, is the armament. There are 10 twin hoist-loaded automatic rocket launcher assemblies. 1 5-inch 38, 4 4.2-inch mortar assemblies, 2 twin 40 mounts, and 4 twin 20 mounts. The twin 20s are handled just like single 20s, except for the dual magazines. 2 loaders are needed. The twin 40s are standard weapons. Each mount has its own gun director, marked 51. The 5-inch 38 is a dual-purpose gun, equipped with a Mark 52 director for anti-aircraft fire. The system's Mark 26 radar set is in the radio room. The computer is in CIC. For surface fire, the 5-inch 38 can be operated by one of the rocket fire control systems. The mortars are fired from modified 3-inch 50 mounts, manually operated. There is no director fire control system. The control is at the gun through open and telescopic sights. The mortars are used for accurate high trajectory fire from 600 to 4,275 yards. Fragmentation, illumination, and white phosphorus shells are available. Other types of mortar projectiles are being developed. The rocket launchers are fully automatic, remote controlled, and fed by hoist from the handling rooms below decks. Rockets are assembled for ready stowage before arrival at the firing area. Motors will be available with various maximum ranges, between 1,250 and 10,000 yards. The short-range motors use larger explosive payloads. Smoke and illumination rockets are assembled in the same way, using different bodies and fuses. The assembled rockets are tanked for stowage in the handling rooms. Now let's assume that all this work is completed. Rockets assembled, tanked, and stowed. The LSMR is in condition 1, ready for battle, but not ready for rocket fire.
Set condition 1, roger. Set condition 1, roger. Prepare all launches for firing. Prepare all launches for firing.
Train and elevation power must be supplied locally before the launchers are cut into automatic control. When all men are clear of the launchers, the hoists are started. Now we're ready to load and fire. The launchers will be operated by the fire control systems. There are two duplicate and independent systems operating a port battery and a starboard battery. Any combination of fire may be selected, however. For example, one fire control system can operate both batteries, while the other system controls the 5-inch 38. The fire control instruments and firing keys are at 3 points: the conning tower, the control stations in the Combat Information Center, and the Intercommunications Room, or IC. The optical control instruments are on the conning tower, a single rangefinder, and 2 directors, one for each fire control system. They're modified Mark 51s with fixed binoculars instead of gun sights. Control is automatic. The director can transmit both train and elevation to any number of launchers. The launchers are selected for firing in the IC room. The stable elements are also an IC. Level is fed to the system for indirect and offset fire. The same output can be used in direct fire, with the director transmitting train only. Other elements are introduced at control stations in the Combat Information Center. There are 2 stations like this in CIC, one for each rocket fire control system. Sight angle and sight deflection are introduced in the gun order corrector. True target bearing is cranked into the train transmitter. In offset fire, the train transmitter is cranked, but the train indicator dial shows the amount of offset. The elevation indicator gives position angle. And there's a director train designator to give relative bearing of the director. Either control center can be used for directing the 5-inch 38 gun instead of the rockets. Range is taken from the SU radar in CIC whenever possible. Range and true target bearing are plotted on the DRT for indirect or offset fire. The 5-inch 38, or the rockets, can be fired from the CIC fire control centers. And that's the LSMR, 1,100 tons of firepower, carrying more destruction per ton than any other ship afloat. Let's see how the LSMR uses her firepower in different tactical situations. Against aircraft. Against surface vessels. The rocket launchers can lay down an effective surface barrage in emergencies. High-speed attack by Jap suicide boats calls for 20 and 40 millimeter fire. Here's the first of the jobs the LSMR was designed for. Neutralization fire against a beachhead just before H hour. The The rocket launchers will be director controlled, both in train and elevation, if the sea is smooth. In rough water, it's sometimes best to have the stable element feed elevation. 300 rounds a minute can be fired. Now the landing craft are moving in. They want smoke on the beach. The troops are ashore, and enemy batteries must be silenced. The ship's in closer now. Details ashore can be observed and appropriate action taken. If the tactical situation permits, the LSMR may be beached. A creeping rocket barrage can be laid down 1,500 yards ahead of the advancing troops. When more is known about the rocket trajectories, it may be possible to decrease this distance. Call fire will be easier to plot and more accurate from the beached ship. Rockets can be used on any call not requiring an accuracy greater than 10 mils. Most harassing fire and fire of interdiction will come within the accuracy limits of rocket fire. The safety of our own troops must be considered, as well as the size of the target. Pinpoint targets will be allotted to the 5-inch .38, fired by one of the rocket fire control systems. The mortars may also be used if the target is within their range. Reverse slope targets require high trajectory. Up to 4,200 yards, they're handled by mortar fire. At greater ranges, the 5-inch .38 can be used with reduced powder charges for high trajectory fire. The LSMR was built to fill the needs of amphibious warfare in the Pacific. Long cruising radius, good seakeeping qualities, shallow draft, ability to beach and retract. Her weapons are designed for offensive action. Neutralization of beach defenses and call fire in direct support of ground troops. But she can use her battery for defense against aircraft and small surface craft. And she has a smoke generator for concealment. The LSMR was built to do one job: fire support of amphibious operations. She works alongside the cruisers and the battle wagons to clear the way for major landings, or she can carry the ball alone in minor operations.